you the session, and the session 1 will be up to 11 a.m.
Okay. Yeah. Thank you, ma'am. Yeah. Good morning to all of you. Let me share my desktop. Yeah. Is it visible?
Yes, sir. It's visible, sir.
Okay, ma'am. Thank you. Yeah. Good morning to all of you once again. Today's topic is exploratory data analytics and predictive data analytics. So these two are very important types of data analytics we use in the general data analytics. When it comes to EDA, this EDA is very important phase in the data analytics projects or the data science projects or machine learning projects. Because using this particular EDA, you are going to understand the type of data you have and the model which is useful to analyze your data using other data analytics techniques like the descriptive analytics and the predictive analytics. These are the different ways, and for these descriptive predictive analytics, this EDA exploratory is very important phase. And coming to my sessions, this is a first session and the second sessions, I'm going to explain this particular topic in a practical manner. Something like the demonstration I'll provide, because you should be in a position at the end of this FDP, you should be in a position to do or continue a research using in this particular domain using some programming tools. So programming tools very much needed to develop a data science project. So here I'm going to cover this with example code, how to do this exploratory data analytics and the predictive data analytics. So here in the data analytics, what I mentioned, major types of data analytics, one is the exploratory data analytics, the descriptive data analytics, and the predictive data analytics. We call the descriptive analytics and the predictive analytics. Let me give a brief details about all these three, then I'll go for in details of exploratory data analytics. Generally, this EDA, what I mentioned, it is much needed in the data analytics even when you are writing research papers. Before presenting results, what you got from the machine learning model or data science model or some other data mining task, you present some of this EDA or the results of EDA before the actual results which are extracted from the data mining or the data analytics techniques. It gives an add-on to your research paper. That's why these days many of the researchers are presenting first EDA results, then followed by the processed results. So what we are going to present here in EDA, raw data. It gives you to understand what type of data set you have. Generally, it is an approach or a philosophy for the data analytics that employs a varieties of techniques. In this, we'll find varieties of techniques. Mostly, the techniques are the graphical. Some of the techniques are non-graphical, which are called the, the quantitative techniques. Generally, we'll refer it as EDA. It is very important and the critical step, first step in the analyzing the data which are extracted from different sources. Why will do? That's the major question. What is the need of this data, exploratory data analysis, EDA? Very first and important the use of this is to detect the mistakes in the data. When you are doing the exploratory analytics, there is a chance to identify the mistakes in the data. That means noise in the data. It helps you to use the best data pre-processing technique to avoid these mistakes called the noise, to reduce the noise. Let me give an example. What is mean by a mistake and what is mean by detection of mistake? One simple example I'll give it to you. You have students data with you. You are planning to analyze your students performance and you're trying to find a correlation between the two different attributes. Those attributes are the students' performance in exit exams or placements. Exit exams means something like a gate kind of exam or placements. And their age. You want to find a correlation between these. Then when you are analyzing your data, you got a pattern like this. Whose age is above 45 are performing very well in campus placements. Your data belongs to UC students, but you got a different kind of pattern, something like the 45 and above. Is that pattern is acceptable? And if you're suggesting or if you're deriving the conclusions based on that, are you going to get a good result or it helps you to take a decision? No, because who says is above 45 is not at all acceptable and it is a meaningless pattern. Because the UG students age is around 21 to 22, 23, 20 to 25 is the UG students age at the time of exit. Right? But you got the pattern. What is that? The different pattern. So that pattern is not acceptable. What is the problem? There is a noise in the data. How you got the noise? Because of the data entry or the data source is not in a position to collect a correct data. Because of that, it's accepted wrong values. Those are the mistakes in the data. If you want to detect mistakes, then you can use this EDA process. You can visualize the data and identify the outliers kind of using different techniques. I will explain to you later how to do this technique, how to do this particular step. With that, you identify the outliers. What is an outlier here? Is above 45. or something like you in the marks column, you got some patterns like this. In my class, 25% of students scored more than 100 in a particular subject, more than 100 marks. But the maximum marks in my subject, the maximum marks itself is maximum in the sense, maximum marks test conducted for maximum marks is 100 only. But in my results or analysis, I got 25% of students are scored more than 100 marks. Is it acceptable? No. That's the noise in the data. That's the mistake in the data. You do EDA and identify mistakes, then remove those noise or mistakes in the data. Checking of assumptions. So you need to assume in the hypothesis. Where many times we'll try to prove or disprove the hypothesis when we are analyzing the data. For that, we need to take some assumptions. These are for checking assumptions, this EDA helps. And the models, which model is suitable for my data set, to identify the models, this EDA process helps. This is the preliminary selection of appropriate models for data science or data analytics. Determining relationship among exploratory variables. So different variables are there. When you're doing EDA, it helps you to identify the relationship. Later on, you go for in-depth analysis and do the analysis on that. And assessing the direction or rough size of the relationship between the exploratory are the outcome variables. Some of the outcome variables and some of the variables. So that is about the descriptive data analytics. Oh, sorry, exploratory data analytics. Now we'll see what is meant by descriptive analytics. This one gives you the data aggregation, or it uses the data aggregation techniques. The data mining techniques, clustering is one of the descriptive technique. Data mining technique to provide insight into the past. So you have a data set. What happened? So what is the purpose is to answer the question, what has happened in the past? You want to understand what happened to your business, or in case of educational institution, you want to understand what type of students you are passed out students details, because you are doing the descriptive analytics to understand the data, insight into the past. That's the purpose of insight into the past. This particular descriptive analysis are the statistics. That's why many times we'll use this statistical techniques in the descriptive analytics. And it describes, what it describes the data set you have, or it summarizes raw data and make it something that is interpretable. So it gives some kind of results. Those results you can, with the help of the results, you can derive conclusions. Interpretable by humans. You can interpret. That helps you to take a decision. So the vast majority of the statistical techniques comes under this particular category, that is descriptive analytics, describing the data set. Predictive analytics. In this particular analytics uses the statistical models like the previous one and forecasting techniques to understand the future of the business. So predicting future, forecasting the business or anything, any domain you can choose, and forecasting, something like the weather forecasting. I want to, based on the existing data, I want to forecast the weather information for the coming week about the wind, rainfall, and the temperature, humidity levels in the next week. Based on the previous results, I want to forecast. Based on the market basket analysis, based on that, I'm going to forecast which item is going to get more demand in the future. So this one is helps you to understand what could happen in the future. So understanding the future is the predictive analytics. Predictive methodologies use the knowledge usually extracted from the historical data. That's what I mentioned. Based on the previous data, we're going to predict the future or unknown events. That is the predictive analytics. 3 ways of analytics. Then let me continue this exploratory data analytics. What are the quantitative techniques that are available, and what are the techniques that are useful for this exploratory data analysis, and what are the graphical techniques that are available, and how to do the implementation of that. Just knowing the concept is not enough. I'll show you one simple, this one, the programming tool I'll use. It's the best for the data science projects, and using that we'll do the EDA process, all graphical and non-graphical. So most of the techniques are graphical and some of the techniques are non-graphical techniques, or called as the quantitative techniques. Let me compare, before going for the methods, let me compare this EDA with a classical data analysis. What we'll do, without EDA also you can do that. What is that? Data analysis. Or you can build a data science project without this EDA. But this gives you more information to understand which particular model is useful. So let me compare these two first. Classical techniques, classical data analysis. A sequence of steps which are involved: problem, defining the problem, a problem statement, or understanding the problem. Then after defining the problem, we'll go for the data collection. We'll collect the data. Then based on the data and based on the problem statement, we are going to choose the model and we are going to build the model. Using that model, we'll analyze the data. It gives some results. Based on that, we are going to derive conclusions. Those conclusions helps for decision making. When you are doing EDA process, problem statement data collection is same. We'll do the analysis before going for model. Right? Here, in the classical one also, after data collection, you can do the pre-processing. Yes, pre-processing is also involved in this. It's a hidden process. So here, when you are doing EDA, this data collection, then after that do the analysis on the raw data, right? Raw data. This is the raw data. Okay, the raw data. And this analysis comes before the model building. Whereas in the previous one, first we'll build the model and we'll do the analysis on that with the help of the model. Now here we'll do the analysis on the raw data, then we'll build the model, then we'll derive the conclusions. I can say here with using this particular phase, there is a chance to get accurate results when compared to this. Okay. So what are the models? When it comes to the model, the classical model imposes the models of both the deterministic and the probabilistic regression models and the ANOVA tests. Whereas in the EDA, not the deterministic or the probabilistic. Okay, that's what. So what is the focus of this classical data analysis and what's the focus of this exploratory data analytics? So the classical will focus on that model building. Whereas this EDA will focus on the data first. That's what after extraction of the data will do EDA process on the data, understanding the data and removing the noise. That's why we'll focus more on the data. This one will focus on the model. When it comes to the techniques, this classical techniques will use the quantitative, something like this ANOVA, t-test, chi-square test, and f-test that comes under the varieties of statistical techniques. Whereas this EDA is a graphical kind of visualizing the data. That's why it concentrates on the data, the major focus on the data. Varieties of graphical techniques. Out of this box plots helps you to understand the data and it helps you to remove the noise. Okay, and the other scatter plots, histograms, probability plots, and residual and mean plots. These are all the varieties of plots. Yeah. So this particular one, EDA, what I mentioned, it classified into two ways. One is the graphical. First one is the method is graphical, non-graphical, or the graphical. The second one is that is either univariate or the multivariate type of. Let us start from the non-graphical techniques. These non-graphical techniques helps you to derive the conclusions. That's what I mentioned in the, and it helps. How do you derive the conclusions on the raw data based on the summary statistics? This non-graphical helps you the summary statistics, and the graphical methods helps you summarize the data in diagrammatic or the pictorial way. Univariate methods looks like one variable, that's one particular column. Multivariate is two or more variables at the same time. So this you can use this to, you can visualize either univariate or multivariate. That means in the graphical you can do both. Okay. Yeah, let me discuss different methods which are useful to in the data exploratory data analysis. The non-graphical methods involve calculation in statistics. Many times the central tendency is student marks. And you want to understand the student, what type of class it is based on a simple central tendency. You want to understand what type of class it is. So let us do the simple central tendency, that is the mean. This is an arithmetic average. So in one particular class, class 1, the students are attending a different subject, subject 1, subject 2, subject 3. Assume that in one subject 40 marks are average, whereas in the other subject 60 marks are average marks. This subject is 50 marks average marks. So same students attended three different classes. Count is same. Assume that 100 students and one class average is less, whereas the other two class averages are, one is 50 and another one is 60. By calculating this average arithmetic mean, you got some knowledge. This class average is low when compared to other two subjects. This particular subject average is low when compared to other two. What is the reason behind this? So this question, what is the reason behind this? Why the students got less average marks? You can go for in-depth analysis to understand the reason behind that. But to understand what type of class it is, you can do a simple arithmetic. So the same students scored different marks. Maybe the reasons are different. Students are not interested, faculty not taught properly, or some other reasons. Maybe their average is acceptable, average is 40 to 50. Something went wrong in this particular subject. Then you can go for in-depth analysis. So this simple non-graphical EDA helps you to understand what type of one it is. Okay. You can apply on any type of data. Suppose you have a placement data. You want to understand the average package in this particular year. So this current year 2021 is average is less, and when compared to the last 2 years, 2019-20 and 18-20. What is the reason behind this? Let's go for in-depth analysis. Okay. Then another central tendency is the median. A middle measurement of a sample set. Example, if you have 9 elements, then you can arrange all the elements in sorted order. The median is a fifth element. In case of 10, fifth and sixth elements by 2 is the median. What is the use of this? The same data set, assume that there are 0, -1 and 1, 2, 3, something like this. Out of 100, when you are arranging in sorted order, this median value is something like in one subject is 30, whose average is 40. Okay, and some other subject is 20 whose average is 50, right? And other one is different. So this middle value, what it gives you, suppose a student X whose marks are 20. So 50% of students are less than this particular student whose performance is less than this. That means in the class 50% of students are this. The remaining 50% are something like this, the mid element. After this, assume that you have 40, then 60, 70, then all the students are coming this range 70 to 100. That's why your average is more. Even the median is low. Okay. When you're calculating the median, some other one median is very low, something like less median value, 20, 21 or 15 only, very less. Because more number of students are there before 15 and very less number of students are there. In the other case is very high, 60 itself is the mid value. So 50% of students scored less than 60 or 50% of students scored more than 50. What is the reason behind this? Go for in-depth analysis. This EDA helps you to understand the data. Mode. This gives you to find the most frequent, which particular one is repeated. This one helps you to understand a type of data and what happened in the, suppose we are all conducting online exams, right? In online exams, you are using online system to evaluate. And the most frequent is something like you conduct it for 10 marks. Most frequent is 5 marks. Why? All the students, maximum number of students are done this. That means why they got only the same value? Why more number of students got that? Maybe reason is different. You go back and do the in-depth analysis. Maybe they copied. That's why the same answer they got. That's why they scored same marks. And more number of such students are there in the class. Okay. Even 100 marks also. There is a chance. And the variance. So this particular variance helps you to understand the deviation from the mean. Suppose you are plotting a linear line, a regression line, assume that. This is the mean, okay? And these are all the positive. Here it starts 0 and this is positive direction and this is the positive one. What is mean by negative? This side is the negative case. But what we are considering it here is a positive only. It is the positive value deviating, indicating the deviation from the mean values. These are the values. Okay. What is the deviation from mean? This is the distance. And this is highly deviated from mean. And this is also more deviation from mean. Why like that? Or what? How much deviation is there from the mean value? So that helps you. This particular variance helps you to understand that. It is the square of sum of deviations from the mean divided by the number of samples minus 1. That's what. This is the formula we'll use, the variance. Okay? Sum of all this, the deviations. This is the mean value. This is the deviation. Okay? And its square value divided with number minus 1. Okay? And it is commonly referred as the sum of squares. Many times when you are building the models and these machine learning data science models, you will find the sum of squares as result. Sorry. As the deviation increases, the variation increase. When we'll get the when this deviation decreases, the variance will decrease. You know, if there is no deviation, you will get the zero, variance is 0. No deviation from the mean, variance equals to 0. How? In this curve, all the values, this is my linear curve. Linear. All the points are exactly in the mean. There is no deviation. This is acceptable sometimes, but not acceptable in some cases. Let us see that. Students' performance, students' marks, and I got the average marks. And there is no deviation, very less deviation or no deviation in the marks. That means all the students were scored same marks. Why? What is the reason behind that? It's not acceptable. The deviation, yet there is no deviation because all are scored same marks. That is the variance. Then the standard deviation, it is the square root of variance. This portion is the variance and square root of variance is the standard deviation, SD. So what is the use of this? I want to group my students using some data mining technique or without using this. Assume that I want to group the students based on a simple statistics. I have 100 students. I want to group the students. I want to form 4 different groups. Z1, Z2, Z3, G4. 4 different groups. On what basis? Based on the mean value. The students who are comes, that is plus or minus mean value, plus or minus x. What is this? My x is the standard deviation. SD value is one group, that is G. Assume that it is G3. So all the students comes under this range. Median plus SD. Something like 0.5 SD is a one group. And median plus 1, median plus SD, median plus 1.5 SD is another group. 3 different. Assume that the 5 different groups we want. This is G3, G4, G5. What about these? Median minus 0.5 SD is a one group, G2. Median minus 1 SD. 1 SD is another group, G1. In one subject, assume that what is the need of this? I want to group the students. Based on that, I want to give a different assignments, or I want to form the groups for projects, final year projects, based on this particular simple statistics. Or I want to grade the students. based on their marks. Okay. These marks are 40 and SD is deviation is 9. Then based on that, I have group. When I'm forming the group, something like I got one group is like this, right? So this is exactly this is the mean, and this is the symmetric. This a 50% is symmetric with the other 50% when I'm doing this. So this is exactly the students are distributed. 50% this side, the 50% is this side. Whereas the other side, in other class, when I'm forming 5 different groups, we got left skewed. More number of students. This distribution is called the normally distributed. This is the normal distribution in statistics. And this is the left side more. So right side less are there. The count, what is this? The count in each group. Assume that in this group, 50 are there or 40 are there. This group is 20, this group is 10. Okay, something like a 15, 10. Then here 20, then 15. Okay, 30, 40, 80, 100. 100 students like this. So more or less normally distributed. But some other case like this, I got 30 students here and 20 students here. 50% is this side. And very less here, average is a 40. So up to this itself is a 90%. It's a left squared or right squared. Right squared, something like this. More number of students. This is my mean value. Okay, here more than 60% of students are coming in this range. So here only this is a 25%, 75% over up to this is a 25% only. So with these statistics, you can understand how what is their performance and what type of class it is. Then the coefficient of variation. You can calculate this coefficient of variation using the below formula. A relative measure of standard deviation when compared to that. This is a general way of calculating that. This is also 1 ED. And another one is quantiles. It's a percentiles. These quantiles are the percentiles gives you the first nth percent of the data values when sorted in ascending order. So something like the in the entire one in sorted order, this is the minimum value and this is the maximum value. And 25th percentile and 50th, then 75th. Minimum to this one. So this is the maximum. Generally we call the 5 numbers summary. 1, 2, 3, 4, 5 number summary. What is the minimum value? Is the 25th, 50th and 75th. Student marks. My minimum marks is 0. My maximum marks in my subject, some students scored 100 out of 100. But when it comes to the 25th percentile, it's very less. Assume that it is 15 marks only, 25. That means 25% of students are there in this range up to 15 marks. Maximum marks is this. Okay. Then 75th and 50th, something like this. You can apply on the data sets the quantile calculation. range. It is the difference between the highest and the lowest measurement of the group. This is also ADA. So from maximum to minimum, when you're calculating the difference, that is the range of the data. It returns the minimum, maximum values observed and the difference of that. And IQR, many times this is required, IQR value to decide to identify the outlier. Just now in the beginning I mentioned that some techniques helps us to identify the outliers. In outlier detection, this IQR is used. So based on the IQR value, will identify which values comes under the outlier. So it is the range from the upper 75 percentile, there's a quartile, to the 25th quartile. So here you have 0, 25, 50, 75, 100. This difference is the IQR. Okay. And IQR plus or minus will decide the lower outliers and the this upper outliers. We'll see that later. So this particular one represents the 50% of the observations occurring in this mid-range from here to here, 25th to 75th. So what is this IQR? How many number of elements are there in this range and what type of data you have? You can understand this IQR value. Yeah, before going for these graphical methods, so the less explanation for the graphical methods, I will show you how to do this in a particular data set. I will take one example data set. And I will show you how to apply all these EDA methods on the data set and deriving the conclusions based on that. Yeah, let me use. So I'm using this a programming tool. That programming tool is a popular programming tool. That is, our programming tool is a popular one for data science. So you're all attending the data science sessions. So if you're familiar with this, it's okay, fine. If you're not familiar with this, it's a very simple, easy to understand. I'm not going to cover the concepts of this. Directly, I'll show you the demonstration, how to use, and I have the demonstration code. Directly, I'll use that. I'll open the script. Yeah, is it visible? The code?
Yes, sir, visible.
Yeah, thank you. Okay, fine. So this is my students' data. Let me use some other data, not this. I'll read the data. X is equal to read.csv. I'm using a method to read. File.choose. This is the general way of reading data into our environment. This is our programming tool I'm using. This is a popular one for the natural language processing and the data analytics and the data mining. Then all these data science, machine learning, for all there are packages and you can use comfortably this. I'm explaining to you accessing the data. Yeah, this data is equal to reading data from my system. So when you're executing this, it opens to you the file. This is you can browse the file using this file directory. So students performance I'm using. And before opening that students performance, let me show you the data set which I have here in my this one 100 students data I have collected. These are the students marks in different subjects, subject 1, subject 2, subject 3 different subjects. They scored marks, and I want to apply all these EDA techniques on this to understand the data. So now the data is this. If we want to display the data, just look at this. This is the data set, and the columns roll number, subject 1, subject 2, subject 3. An additional column is there. I want to remove this particular one. Yeah, to remove that, the data is equal to data 1, 2, 1, 2, 3, 4. Total 4 columns I want. How many number of columns you want? You mention that. I'll get only the columns which are. If you want to understand, say what are the column names, then these are the column names. And if we want to do the exploratory data analysis, so let me execute x is equal to, here I'll run the mean value. So x is equal to my subject 1 data dollar subject s1 in this see here 50 is the mean value of this particular subject 1. In the same fashion, let me do it for other columns. S2 mean value is 43, S3 mean value is 65. See, the same class, same students, but the marks are different marks they scored. So what is the reason behind this? We'll do it in-depth analysis later. At present, using this particular central tendency, we got the average marks. Then after that, you can calculate the median of this of data dollar S1 is 51, right? Then the S2 is 46, S3 is 66. See, if you look at the mid values of these, the first one mean is 50, mid value is 54, and the second one mean is 43, and mid value is 46, whereas the 65 and the 66. That means it looks like equal number of students are there before mean value and after mean value. That's why the mid values are also near to this. But sometimes we'll get the mean value is a high. Even though mean value is a high, we'll get the median value is a low, because more number of students less than mean value, and very few students which are high score, something like a 99, 98, 90, 90. Above 90, there are good number of few students are there. Because of those students, average is increased, but the mid value is low. You can do this on your campus placement data on their packages. Mean value is high or reasonably good. Even though the mean is reasonably good, when you are doing the median, suppose the mean value is something like 6 lakhs per annum mean value, and it looks good, and the median value is very low, something like a 2.5 median. That means less than 50% of students are got the placement with a less offer, that is the less salary package is less. Why the mean values are high? Because more number of because some students with very good, something like the 25 30 packages, because of them this average is increased. Like that you can do the median mean values. And in the same fashion, I want to know with the repeated value, but there is no function for that directly to calculate the mode. Uh, so I use this uh, simple function to calculate the mean value. Okay. Yeah. Yeah. Let me display the mode directly. Mode is 63. Marks 63 is repeated in that. What is my x? X is equal to first subject. Let me display that. Yes, 1. In this, 63 is repeated more number of times. Look at 63 here and 63 here. Here also 63 is there, 63. So marks 63 is repeated more number of times. And how many number of times, certain times is repeated in the data set. So that is mode calculation. And let us see this variance and the standard deviation. These two helps us to distribute the data set. And for one particular this one, variance is and the deviation is this, and and the mean value of this x. See, deviation and mean values. Mean is 50 and deviation is 17. What I mentioned, I want to group the students into four different groups. These groups uh, based on the mean value. So mean is 50, something like 0. SD. This is SD is equal to, let me use S is my SD, and S by 2 is the deviation. So mean value is M is the mean, and here M value is this. Something like a m plus the deviation s by 2, that is half of the deviation is the range in my cluster in one particular group. So around this 50 up to 59, then something like this, 50 to 59 is one group, or something like a 47 to 59 is one particular group. All the students' marks, whose marks are between these two, comes under one group. And another one is something like a mean and standard deviation. One SD is 68. So around these marks is another group. Then in the same fashion, you can do 1.5 is D. This is multiply with 1.5. So it is 76. Around 76 is one group, 68 is another group, and 59 is another group. In the same fashion, you can do it mean minus S by 2 of the SD. 42 is a one group, then S is another group, 33 is the. So I want to group the students into 5 different groups. So group 1 is 33 marks, around 33 up to 33 marks, or around 33 you can consider, and 42. Then another group is 59, 68, and 76. Like this, you can group the students, can form the groups, and then count the number of students in each group, and based on that, you decide what type of class it is. Okay, based on their performance. So another covariance is this is the way of calculation of that. So covariance is 34. And let us look at the quantiles. This gives you an interesting insight, the data, and using this you can understand the data. Quantiles. See, look at the quantiles in my subject, in one particular subject. Let me do this for the other subjects. This is dollar S2 S3 subjects for 3 subjects. Yeah, 0. This is the 0th percentage starting from 0. So in my class, 0 marks student is there in subject 1. This is X means subject 1, or else I'll show it again, the S1. Say subject 1, subject 2, subject 3. It's one subject. In all 3 subjects, approximate 0, 0, 0, and 0.5 marks are there in one class. So look at this. 50th students marks are less, 46 only, but in that class highest marks scored is 99 marks scored one student. Even my 50th value and IQR values are low, are the minimum. In case of 5 number summary, the minimum value is less. That is that 50 is the minimum value. Even the minimum values are low. In that particular subject, maximum marks student, one student scored maximum marks, that is 99. Look at some other one. Minimum is 0 in this subject. My 50th value is 50th percentile is 66, and highest is 95 only. So here 50th itself is high, okay, but the highest is a low. Whereas in this one, 50th is thus 54. So I can understand in this data set, say from 41 to 61, 50% of students scored marks from 41 to 61 in this subject, and 50% of students scored in this subject from 54 to 79. That means a good number of students scored good marks in this particular subject. Whereas, look at the subject 2, 34 to 75. 34 to 75. This is 34 to 53. 34 to 53 are only marks are, say, lower boundary is a low and upper is also low in this particular case. That's why 50% of students scored from 34 to 53. Look at the mean values of these. Just now have seen mean value of data dollar S1. Just this the above one. See, average is 50, but maximum students are there in the range of this 50% of students from 41 to 61. For subject 3, subject 3 is 65. That's the reason average is high, because 50% of students are there in this range from 54 to 79. Okay, this is the quantiles. In the same fashion, you can use the summary. 5-number summary. It gives using the summary function. Subject 1. Look at the minimum is this. First quartile is 41 and the median value is 54. Look at this. This is the median value 54 and the mean is 50. Third quartile is 61 point. This is 75th. And maximum is 91 point. Either quantile, or this summary you can use to understand the data set. So all three subjects, 41 to 61 and 34 to 53 and 54 to 79 are the ranges in this. Yeah. And the range between what is this, the from first quartile to the 75th quartile, this range function gives, and the difference between is 91. See the range from here, sorry, not this to the range it gives you from minimum value to the maximum value. So what is the range from 0 to 91? The difference is 90. Okay, so in the other subject, data $S2, 98 is the difference, but I want range. The range is 0.5 to 99. Then S3 is up to 95. Then 95. Look at, these are the different statistical methods which are used to understand that. Let me display this IQR value, IQR of X. IQR is interquartile range from 25 to 25th percentile to the 75th one. Let me show you this. S2 is 18, whereas the IQR value of S3 is 25. So here to here, then yeah, these are the different techniques which are used. And let me go to the presentation again, how to calculate this and how to interpret. See, very, very important thing in data science, data analytics, machine learning. If you have a data set and if you have some tool, then when you are executing these the varieties of statistical methods or varieties of non-graphical and non-graphical in case of ED or even the other analytics like the descriptive and predictive analytics, you will get the results. You should be in a position to interpret these results. That's what an important thing here. Okay, so let's move to this, the graphical thing. So range and IQR values. Okay, graphical methods. These graphical methods helps you to visualize the data. The bar plot, where each bar plot represents the frequency observations of for a group. So what is the size of group? Then it gives the number of observations, the count or n in the graphical, this one, the bar plot. Let us see the bar plot and the histograms and the same data set. Histogram is also a plot where each bar represents the frequency of observations for a given range of values, right? Let us apply these two techniques on the same data set. I'll show you. I want to plot this. One is the histogram and the data set and one particular subject S1. Look at the histogram, graphical representation of raw data. See, in the range from 0 to 20, how many number of samples are there? 20 to 40, how many number of samples are there? 40 to 6, how many number of samples are there? then 60 to 80, and 80 to 100. See, if you visualize the data, easy to understand what type of data set you have. See, the student marks in this subject S1, from 70 marks to 100 marks, very less number of students are there, and all the students comes under the range from 50 to 70. See, 50 to 70 range, more number of students are there. The count is around 50 to 60, is 30 students are there in the class. That means 30% out of 100, 30% of students are there in this range. And this one, look at this, is around 25. So around 55 students are there from 50 to 70. Whereas the bar plot is, so it gives you the frequency of each one. 100 students, these are 100. If you want to see which student scored less and which student scored more, something like a student 1, number 1 scored around, this is a 10. So let me show you this data set. Yeah, around, see, this is first student, 11 scored. This is around 10, that's what. Something like one student scored 0 here, and few students scored less marks. One student, these 4 students or 5 students scored very good above 80. Isn't that in this data set, x is equal to this, okay, and x is equal to, I want to modify this by combining this in this x comma 150 is this. When I am doing this bar plot on this particular x, say, so one particular student is scored around 140. Is it acceptable? This is an outlier in the data set. Suppose if you are doing the statistical analysis and the entire data set, your mean value is a high. I'll show you the mean value of this is 51, whereas in the previous case it was less because data dollar S1. Let me show you this. This is 51. Because of this, it is increased one level. This 50, no, 1. That's the mean value because of this one. Why? One student scored, and this is not acceptable. So it is something like an outlier in the data set. I want to remove this outlier, right? So there are different methods to remove outliers. Identifying the outliers only the duty of this particular EDA, and removing that again we'll use the outlier detection, outlier removal techniques in this one. So these two are. Let me do this, the histogram for this. Histogram of X. Yeah, when you are doing the histogram, say the range is 0 to 150. From 100 to 150, no students, but at 150 there are one student is there at 150. So these are acceptable, and this is an outlier in the data set. So that particular outlier we need to remove. So removal of outlier is required in this one. Okay. Then yeah. Plot and the this histogram both gives you the different ways to understand the data and to see what kind of data set it is, and understanding any outlier is there, identifying outlier and removal of outlier is possible with this one. So density is an estimation of the frequency distribution based on the sample data plot density. Then, yeah, let us see the other box plot and quantile visualization. This is very useful in this one gives you the plot of the actual data values against the normal distributions, QQNR. And Bakshwishkar is the scientist who proposed this particular one. It is a visualization of or the visual presentation of the median, quartiles, then the this one symmetry, skewness, and outliers all together in a single one you can represent using this box plot. Then the scatter plots and the line plots are also helps you to understand. Yeah, these are all the different techniques which are used. The first, let me explain about this box plot and its uses and in this one. See what I mentioned in the statistical methods. These IQR values, the entire data set is here using box plot. We are representing the data using 5-number summary. 5-number summary means the minimum value and the maximum value. Then the first 25th percentile, that's the first quartile, is this, and the median value. This is the mid value, and 75th percentile. From Q1 to Q2 is the IQR. This portion of the data is called IQR. And this from here, from Q3 onwards, upper whisker, and from 0 to or below that, below the 25th, this is the first quartile, it is a lower whisker. And the outliers are there both the sides, left and the right sides. Let me give an example. Suppose you are plotting the data on students' age. What is their age in the particular class, minimum and maximum, then the 5-number summary. When it comes to the outliers, there are students in the class whose age is a negative age, or it is very less, something like a 10 or less than 10. Is it acceptable in case of UC students? No, it's not acceptable. So what we'll do, the quartile 25th percentile to the 75th percentile in this range, that is the interquartile range, IQR. This IQR multiply with 1.5. IQR multiply with 1.5, subtract from Q1, that is the 25th percentile. If all the values which are coming below this Q1 minus 1 multiply with IQR, 1.5 multiply with the IQR, then that is the lower outlier. That means the outlier whose values are less than the minimum, less than the Q1 is this, the lower quartiles. And the upper quartiles are the upper whisker is this is outliers at upper side is Q3, that is the 25th percentile plus 1.5 multiply with this IQR value. All the values which are coming outside of this are comes under the outliers. Let me show you this particular one on the data set. Box plot. Data dollar. Yes, one. Box plot data dollar S1. Let me show you this. Yeah, look at this. There are outliers in the data set. See, below this one, IQR range is this, and let me IQR of this X is a 21 is the IQR, and median is of X is at 54, median is 54, and the minimum value is, let me do the summary. See, the minimum value is 0 and the median is 54, that is the mid value. This is the median value is 54 and the mean value is around this, around 51, and the this is the third quartile here. This is around 63 and maximum is 150 and 0 is this. So this is the visualization of that. So you can compare side by side all the subjects. Subject 1, data dollar, S2, data dollar, S3. This helps you to understand, this helps you to compare side by side all the subjects. Let me show you this again. Let me visualize again by separating something like combine. Three different colors I want, because this helps you, us to understand and to distinguish easily between the different subjects. Look at the subject 1. See, this is, see, the IQR 25th percentile of subject itself is almost median of this. Whereas in the subject 2, see, the maximum value is low, the maximum is high. There is a maximum value and minimum values, but this is an outlier in the class, and this is an outlier in the class. This is also an outlier. And in the range, this is the 25th quartile, 30, this one. These are the outliers, and the minimum and maximum values are like this. When compared to these two subjects, and in this subject performance is low at an average, but one student scored high marks. What is the reason behind that? Let's go for in-depth analysis. Maybe the student copied, because of that he scored maximum marks in this particular subject, and the other subjects, the other students scored very less. Maybe these are the lower side of this, what is the outliers. So this is the outlier detection method. Yeah. So in the same fashion, you can do the histogram. Yeah, already done the histogram, and the normal plot. You can plot it and compare two different subjects by plotting. I'll show you one example. You can compare the multiple subjects with this, and using some other technique also, some other one, that is the plot of data. Entire one I want to compare. So look at this. Look at this. Here, this is the comparison between subject 1 and the student's marks. So this particular comparison, it gives the comparison between the two. One is subject 1 and subject 2. subject 3, and so on. This is the comparison between the subject 1 and subject 2. And comparison between the subject 1 and 3 is this. And comparison between this, plotting the data and visualizing that. And just you can plot only one particular subject using this subject 1, and so it shows to you the visualization of the data. So where are the samples? The more number of samples are coming in this range, something like the 41 to 55, and this is the index student marks. This is the student 1 and the last student. See, the last student marks are this. Okay, different students marks it shows to you. In the same fashion, let us see for the subject 2. See, in this subject, all the students are coming from the range 60 to 20 only. First student marks are less, and even the last student marks are also less in this particular subject. Like this also you can compare why this particular student scored more in one subject, whereas the same students scored less marks in the other subject. Like that also you can compare side by side. Okay, then so line types and other things, something like a line, drawing a line, line type of plots and other things are also used in the EDA, exploratory data analysis. Then can do the multiple correlations. So that's what the multiple correlations will do between the different attributes. Or else if you want to do this comparisons between only two, this you can do plot. Let me do one simple example. Plot comparison S1 plus S2. S2 data is equal to data. This is just comparison between the subject 1 and the subject 2, how the marks are varying between these two subjects, and with this you can understand the data. So if you want to do the multiple comparisons in one particular one, you can compare like that. So this is one example data set I have taken and have given the explanation based on this. So in the same fashion, you can choose your own data set and you can apply all these EDA techniques on your data set and derive some conclusions using this EDA itself. Or you can choose which model is suitable for the data analysis and other things. So this is about the EDA. Before closing, these are all the varieties of functions I have created, and let me take some questions, because the first one before moving for the predictive analytics, with this this exploratory data analytics is over. So before moving to the next one, let me take some questions and let me answer the questions first. Any queries?
Thank you, sir. I request all the participants, I request all the participants to ask any questions.
Hello, sir.
Yeah.
So, till now what we discussed, this is totally related to data scientist or data analyst, sir?
You can't distinguish exactly, this is required for only this skill is required for data scientist or the data analyst. This is a mandatory phase or very much needed phase for all the data analytics projects, data science projects, even the machine learning projects. This is very much useful, right? It's not belongs to a single one. This
Okay.
is very useful phase in the data analysis, or if you are building a model, data science model, this is a much needed phase.
Okay.
So
Okay.
you need to understand. And one more thing I want to convey here. See, in all these three domains, analytics, data science, and machine learning, the maximum of the time, 40 to 60% of the time, the developers are spending on pre-processing,
Yes.
because the results of the outcomes of the model are depending on the quality of the data, input data. Quality of the results are depending on the quality of input data. So it is a mandatory